In this chapter, we will be discussing cryptography and all the various forms and encryption method that deals with cryptography. Public key certification. This is a digitally signed document to validate the sender's authorization and name. The document consists of a specially formatted block of data that contains the name of the certificate holder. In this scenario, the people who are using this public key to encrypt the messages that were intended for individual B will actually be sending messages to individual A. Because individual A has the private key that corresponds to the posted public key, individuals A can now decrypt the messages that were intended for individual B. Digital certificates. Digital certificates are used to encrypt online communication between an end-user browser and the website. After verifying that a company owns a website, a certificate authority will sign their certificate so it is trusted by internet browsers. If we examine this diagram, we will see a layout of how a certificate would follow. So if you look to the left of the diagram, you would see the public key, and it will have the website, whatever website it is that the company owns. For example, let's say msn.com or amazon.com, followed by the company that owns the website, and then you will get a validity date of the certificate, meaning you will get the certificate when it is valid from and when until when it is valid to, right? I'm sure probably some of you, I don't know if you ever came across an error in most likely one of the browsers such as Internet Explorer. This is probably a little while back, sometimes if you try to go on a particular website, you might get an error coming up in red, or whether it is Chrome, you would see an error in red that the certificate for the particular site that you're trying to access has expired. It is unsafe to proceed. Do you want to proceed? Right? That is a typical error you would get if the certificate for the website you're trying to access expired, or they doesn't have a valid certificate. So we can say, extending on digital certificates, we can say a certification process involves binding individuals to their public keys. The certificate authority acts as a notary by verifying person's identity and issuing a certificate. Hi, in this slide we'll be discussing public key infrastructure, another form of cryptography. Before we move on, let's briefly look at the flow diagram of how PKIs function. Paying attention to relevant details such as the issuing certificate authority, followed by the registration authority, and also the certificate revocation list. In the next slide, we will go on to explaining some of these things in more details. Let's discuss some other features of PKIs. PKIs allows the integration of digital signatures and certificates and the other services that require for e-commerce. These services provide integrity, access control, confidentiality, authentication, and non-repudiation for electronic transactions. In order for PKIs or public key infrastructure to function, there's a protocol that there's a protocol, it functions via a protocol. This protocol is known as the Lightweight Directory Access Protocols, which provide a standard format to access the certificate directory. Directories, on the other hand, are stored on lightweight directory access protocols servers on a network, and these servers provide public keys and corresponding X.501 certificates for the enterprise. Approaches to escrowed encryption. Basically, this slide will be discussing how law enforcement agencies get access to encrypted messages being passed over the internet. So for instance, let's check out point number 1. Law enforcement agencies are granted access with encryption keys to read enciphered messages that are transmitted over the computer network. For example, information is transmitted. If law enforcement agencies, should the need arise, require access to these encrypted messages, this is where escrowed encryption comes in. However, with accessing encrypted information, certain features need to be guaranteed. Because let's think of it. The data is already encrypted. It would have been encrypted to protect citizens' privacy, right? So with this process, citizens' privacy is protected from illegal and unauthorized surveillance of their digital communication. So whatever methods that they use, whatever methods the law enforcement agency uses, it needs to also be mindful of citizens' privacy when accessing encrypted information. Encryption and standards. This standard was developed in February 1994 by the National Institute of Standards and Technology. This standard strives to achieve individual privacy and at the same time strives to provide for legal monitoring of the encrypted transmission. So at the same time, although your information is encrypted, there is a standard that was developed to monitor these encrypted transmissions over the internet. So there is someone policing and monitoring your encrypted transmissions, right? With this standard, keys are divided into two parts and escrowed to two separate organizations. Once a court order is obtained, the two keys are combined and decrypted. So basically, we are seeing here that in order for successful decryption to be taken place, because with this in mind, remember we discussed in the previous slide that it is illegal for citizens' privacy data to be exposed, right? So a court order needs to be obtained, and then the two separate parts of the keys are combined before you get access to decrypt the encrypted information. In 1992, Silvio Milcali introduced the concept of fair crypto systems. One valuable characteristic of Macali's approach is that each portion of the secret key can be verified as corrected without having to reconstruct the entire key. The private key of a public/private key pair is divided into multiple parts and distributed to different trustees. This is accomplished by giving each trustee a piece of each public key and private key. So here we will be discussing some of the key management issues when dealing with cryptography. When dealing with encrypted keys, precautions must be taken. Some of these precautions are key control measures, key recovery, key storage, key retirement and destruction of keys, key change, key generation, key theft, and also the frequency of key use. Those are a lot of key points to be discussing there. Cryptography also covers email security issues and approaches. Some of the main objectives to email security are to ensure the following, which includes non-repudiation. Messages are read only by their intended recipients. Key point there. For example, if a message is being sent to recipient A, recipient B should not receive the message or be able to read recipient A message, right? Integrity of the message, authentication of the source, verification of delivery, labeling of sensitive material, and control of access. All of these points are key when dealing with email securities and approaches. Here we will be discussing some of the standards that were developed to address some of the email security issues. SMIME, Secure Multipurpose Internet Email Extensions. Secure services are added to emails via authentication through digital signatures and confidentiality of encryption. SMIME uses X.509 standards for its digital certificate. MOS, MIME Object Security Services. MOS provides flexible email security services by providing support for different trust models. MOS is utilized for authenticity, confidentiality, integrity, and non-repudiation for its email messages. It uses Message Digest 2, MD2, and MD5 algorithms, Rivest, Shamir, and Adelman's public key. That is the RSA key. And data encryption standards, DES, to support authentication and encryption services. PEM, another form of standards that were developed, stands for Privacy Enhanced Mail. This is where an email encryption mechanism that is used to allow authentication, integrity, and confidentiality. It uses RSA, DES, and X509. This was developed by a consortium which included Microsoft, Novell, and Sun Systems. So it also supports encryption and authentication of Internet email. Another standard includes Pretty Good Privacy, PGP. This is an asymmetric public-private key system that uses the ideal algorithm to encrypt, decrypt, and digitally sign files and email messages. It is not standard, but is widely supported on the internet. This was developed by Phil Zimmerman. Here we will see an example of how PGP works. So if you look, you would see we have a raw file, then it is encrypted with the public key, which now becomes an encrypted file. Then it goes to via email or FTP. That's the encryption process. Decrypting now, well, decrypting is basically from right to left now. So we would have the email that was encrypted. Then the encrypted file is decrypted with a private key and then goes to a raw file. So basically, we just examine some of the forms, standards, and functions of cryptography. Thank you for listening.